Good morning all, welcome back. In this video we are going to discuss about the rest of the two asymptotic notations. Okay, already we have discussed that the notation, it is the mathematical concept which is used to describe about the behavior of a algorithm, and also it is focusing on the uh, time and space complexity. For analyzing that, we are using the three types of uh, notations. From that, totally 5 types of notations are there. From this, already we have discussed the 3 types. Next we are going to discuss about the little o notations. The little o notation is used to describe an upper bound that cannot be tight. Okay, it will be a slower growth rate, and also it grows slower than g of n. Let's f of n and g of n are the function which that map the positive real numbers, and we can say that function f of n is big O of g of n if there is a positive constant exist. And for this it will use we have to use the mathematical relationship that is represented in f of n equal to O of g of n. An example of this little o asymptotic notations. Then another asymptotic notation is little omega notation. It is denoted by omega. Okay. Then little omega notation is used to describe a lower bound of f of n, and also it will provide the fast growth rate, and the f of n grows faster than g of n. Then the little o omega notations are represented by using limitations n tends to infinity, f of n divided by O of n equal to 0. It formally stated as f of n equal to w of g of n. Examples for this asymptotic notations are, you can consider the problem. We have to find the upper bound, lower bound and tight bound range of function f of n equal to 2n plus 5. Let us consider the given that f of n equal to 2n plus 5. Now g of n equal to n, the lower bound is 2n, upper bound is 3n, the tight bound is 2n. For big O notation, according to definition, f of n is less than or equal to c into g of n for big O. We use upper bound, so f of n equal to 2n plus 5 g of n, then according to the definition 2n plus 5 less than or equal to 3n. Put n equal to 1. 7 is less than or equal to 3. No, false. Put n equal to 2. False. N equal to 3. Again false. N equal to 4. Also false. N equal to 5. Condition is become true. Now, for all values of n is greater than or equal to 5, above condition is satisfied. The next one is the big O notation. That represents the lower bound. Same example it is given here also. We get a 7 greater than 2 true. Okay. In that case n is greater than or equal to 1 and c is equal to 2. Condition is satisfied. In this you can consider f of n is greater than or equal to c into g of n. This is already we have discussed in the omega notation. Okay. It is used to represent the lower bound notations. If so, c equal to 2. You can consider this f of n equal to 2n plus 5 and g of n equal to 2 into n. 2n plus 5 greater than or equal to c into g of n. It is 2n plus 5 greater than or equal to 2n. Put n equal to 1. So if so, then we will get a 2 plus 5 is 7 and this side 2. Condition is true. For all values of n equal to greater than or equal to 1, c equal to 2, condition is satisfied. This theta notation, according to the definition, C1 dot g of n less than or equal to f of n less than or equal to C2 of g. Thank you. This is the reference book and also a textbook. Thank you.